Hi everyone, I am Miss Jarina. In today's lesson, we are going to learn about limestone and building materials. Okay, so before that, let us do a quick recap of what we learned on Friday during the combined class. On Friday, we learned about the chlor-alkali industry. Okay, so let me ask you a few questions. Name the electrolyte in the chlor-alkali process. So chlor-alkali process is an electrolysis reaction. So there was an electrolyte that was used. What's the name of the electrolyte? Okay, good. It's concentrated sodium chloride solution. Okay, good. Name the anode and cathode in the chlor-alkali process. What is the answer? Correct. The anode is made of titanium and the cathode is made of steel. Okay, well done for the student who answered. Moving on. Name the 3 products obtained during the electrolysis of brine. Okay, so what is brine? Brine is concentrated sodium chloride solution. Okay, so what are the 3 products obtained? So we learned that during this process, from one electrolyte, we get 3 different products. What are they? Okay, good. One is hydrogen gas. All right, the second one is chlorine gas. And then the third is sodium hydroxide solution. Okay, very good to those who answered. Name the product formed at the anode. Okay, I do see some answers as chloride ion. Chloride ion is not the product. Yes, it's correct that the chloride ion moves towards the anode because chloride ions are negatively charged and anode is the positive electrode. But here the question is name the product. So the product is a substance. If the question asks you name the ion, then only you give the name of the ion. Here you're asked to write the name of the product. Okay, so the product here at the anode is chlorine gas. Even if you just write chlorine, that would be fine. But if you write chloride or chloride ion, no marks will be given. Okay, so please read the question carefully. Okay, moving on. Name the product formed at the cathode. Okay, good. I see an answer. So at the cathode, it is hydrogen gas. Okay, moving on. Why is hydrogen gas formed at the cathode and not sodium metal? So in the electrolyte, you will see that there are 2 positive ions, sodium ion and also hydrogen ion. But why is it the hydrogen gas is formed and not the sodium metal? Okay, can I have the answer, students? Okay, good. I see an answer. Sodium metal is more reactive. So hydrogen is discharged. Okay. So here there are 2 things that are in question, hydrogen gas and sodium metal. So you have to specify what you're talking about. If you just write it is more reactive, I will not be able to know which one you're referring to. Are you referring to the hydrogen gas or are you referring to the sodium metal? So you have to be very clear about that. Okay, so sodium metal is more reactive, so hydrogen is discharged. So sodium, so that is the reason why sodium is not obtained at the cathode and we get hydrogen gas. Okay. All right, moving on. State the half equation at the anode. Okay, good. So at the anode, the chloride ions lose electron to form chlorine. So chlorine is a diatomic molecule. So it is Cl2. So when you balance the equation, it would be 2Cl minus gives out 2 electrons, or 2 chloride ions give out 2 electrons to form chlorine gas. State the half equation at the cathode. Good. So at the cathode, hydrogen gas is formed. So hydrogen ion, each hydrogen ion will take 1 electron to form the hydrogen atom. Now hydrogen again is a diatom, again forms a diatomic molecule. So it is H2. So 2 hydrogen ions take up 2 electrons to form hydrogen gas. Okay, good. State one use of hydrogen. We've learned a few uses of hydrogen. State one use. As a fuel. Okay, good. It's used as a fuel. State one use of chlorine. To sterilize drinking water, to kill bacteria in swimming pool, to make bleach. Okay, so there are quite a number of answers. You only need to give me one use. To kill bacteria in swimming pools. Be a bit more specific, student. Do not just simply write swimming pool. Okay, so what is the purpose of adding the chlorine to the swimming pool? It is to kill the bacteria in the water. Okay, so if you just write swimming pool, drinking water, it doesn't have any meaning. You need to be a little bit more, give a little bit more information, though it is 1 mark. Okay, all right, next one. State one use of sodium hydroxide. To make soap. Okay, good. State one use of fluorine. So when we learned about the chloralkali industry, we also learned about the uses of the other halogens. Used in toothpaste. Okay, so it is added to toothpaste to prevent tooth decay. Okay, good. So that was a short recap of what we learned in the previous lesson. So let us move on to today's lesson. Okay, now today's lesson is about limestone and building materials. Now rocks provide essential building materials. Okay, so if building materials here refers to those substances that are used to build our homes, offices, shopping complexes, and all these. So rocks provide the basic building materials. Now, why are rocks used as building materials? Because they are very durable. Okay, number one, rocks are very durable. They are fireproof, and they can even withstand earthquakes. Most of the time, they can even withstand earthquakes. Many types of rocks are used as building materials, and limestone is one of them. Okay. Now, one thing about this subunit is that it is quite a simple unit when compared to others, because it kind of brings all the properties of limestone in one place. Only later on you learn with some of the things that will be new will be about cement and concrete and so on. Okay, all right. So limestone is a naturally occurring resource, and it is used to make glass, cement, and concrete. Okay, so limestone can be obtained naturally. All right, now what is the chemical formula for limestone? Who can tell me? Yes, correct. It's CaCO3, calcium carbonate. Okay, the chemical formula for limestone is calcium carbonate, is CaCO3, which is calcium carbonate. Okay, so this is the name. Limestone is chemically calcium carbonate, and this is the chemical formula. Now, limestone can be thermally decomposed to make new products. So we've learned about this before. All right. So what happens when limestone is thermally decomposed? What products are formed? Yes, correct. Okay, you get calcium oxide and carbon dioxide. Now, what does thermally decomposed means? Thermally decomposed means it's heated. Okay, so when limestone is heated, you get calcium carbonate and when limestone is heated, or when calcium carbonate is heated, you get calcium oxide and carbon dioxide. So the limestone can be used as such, or it can be heated and the calcium oxide can be used. Okay, both ways it has a lot of uses. Okay, all right, so let's see what are the properties of calcium carbonate. Okay, now calcium carbonate, as I mentioned earlier, is composed of calcium carbonate is a chemical name for limestone. Okay, as I mentioned earlier, it is quarried and can be used as a building material. Okay, so you look at this picture here. That's a picture of a quarry. Okay, so I've given an explanation here for what a quarry is. A quarry is a place. Okay, a place, typically a large deep pit, a hole from which stone or other materials are extracted. Okay, and in this picture what you have is a limestone quarry. Okay, so you can see that this limestone being around. Now, calcium is not a transition metal, so calcium carbonate doesn't have any other color. It is white in color. All right, so this is a quarry. Okay, now let us see what are the advantages and disadvantages of using limestone as a building material. So earlier we saw that it's a kind of rock, so it is durable and so on. But what advantage does limestone have? Now, limestone is cheaper than using lime. Okay, now what is lime? Who can tell me what is lime or quick lime? Okay, it is calcium oxide. Okay, so limestone is cheaper than using lime, but there are also certain disadvantages of using limestone. Okay, the first one, wildlife habitats are destroyed. So when you look at this image, you can see somewhere far away here some trees here. So once upon a time, this particular area should have been a forest or a jungle where wild animals lived. So now they do not have their habitats. Okay, their place of living has been taken away. Valuable agricultural land is taken away. So agricultural land is land that is used to grow crops like rice and other food crops. Okay, now but what happens here? Now if you look at this particular area here, it's also empty, and by the time they clear everything and then they have to grow crops, it will take a long time. So agricultural land is taken away. Quarrying creates pollution from noise and dust. Okay, the place is going to be noisy because of the explosion of the explosion that is created, and then the dust and so on. Okay, dust pollution and so on. Limestone is a non-renewable resource, so it will only last for a certain period of time. People keep on taking it from the ground, and then at one point of time it's going to finish. So it's a non-renewable resource. Okay, so though there are advantages of using limestone as a building material, there are also some disadvantages. All right, so let's move on. Now, calcium carbonate can be decomposed, calcium carbonate can be decomposed. So this we already, this equation we come across a few times in chapter 8 and also the first part of chapter 9. Okay, who can tell me where did we come across this equation before? Okay, good. That's during the extraction of iron. Yeah, the extraction of iron from iron ore. During the extraction of iron from iron ore, calcium carbonate is used. Okay, all right. Now, what can calcium oxide be used for? Who can tell me? Calcium oxide is a basic oxide. What can it be used for? Okay, so let's see what calcium oxide can be used for. Now, in agriculture, to neutralize acid soils. Okay, so just now I told you calcium oxide is a basic oxide. It's a metal oxide. It's a basic oxide. So it can neutralize acidic. It can neutralize the acid in soil. Now, what makes soil acidic? We have learned this before. What makes soil acidic? Okay, correct. Soil becomes acidic due to constant use of fertilizer and also due to acid rain. So all these will increase the acidity of soil. So calcium oxide is is put in the soil to neutralize the acidity. Now, calcium oxide can also be used to make glass. Together with sodium carbonate, it is heated together with sodium carbonate and sand to make glass. Okay, so in the blast furnace, it is used in the extraction of iron. Okay, so we've seen in detail how calcium carbonate decomposes to form calcium oxide, and the calcium oxide reacts with acidic impurities to form slag. All right, so it is used in the extraction of iron. So these are some uses of calcium oxide. Now let's look at some reactions of the carbonates. Okay, so when we learned about when we learned about the action of heat on substances in chapter 8, we learned that sodium carbonate and potassium carbonate do not decompose on heating, but the other carbonates, they decompose. Okay, so who can tell me what products are formed when magnesium carbonate is heated? So it says here, the carbonates of magnesium, copper, zinc, and calcium decompose on heating in a similar way. Okay, good. What products are formed? The products that are formed are magnesium oxide and carbon dioxide. Okay, copper carbonate, copper oxide and carbon dioxide. Calcium carbonate, calcium oxide and carbon dioxide. Okay, now who can remember the color of copper carbonate? When I did this topic in chapter 8, I showed you a video of the decomposition of copper carbonate. What is the color of copper carbonate? Green, yes. The color of copper carbonate is green. It's a green solid. Copper sulfate, dehydrated copper sulfate is blue in color. Copper carbonate is green in color. Okay, so from calcium carbonate, you get calcium oxide and carbon dioxide. Now, calcium oxide reacts with water to form calcium hydroxide. All right, so this is the equation for the reaction of calcium oxide with water. Now, calcium hydroxide is also an alkali. Okay, so you see hydroxide there. So calcium hydroxide is an alkali. Therefore, it can also be used in the neutralization of acids. When might it be useful to neutralize acids on a large scale? Okay, so the question is asking you to give an example of where acids can be neutralized in a large amount. Of course, in the labs also they are used, but it's in a smaller amount. In a large scale, where is it used? You have learned this, okay? So you can answer from what you have studied. Okay, good. Yeah, it's used in agriculture, we saw just now, right? In agriculture, to neutralize acidic soil. So this is done in a very large scale. Okay, so this is one example that you can see. All right, now moving on, let us look at some of the reactions of calcium carbonate. Okay, so these reactions you have learned before. It's all kind of summarized here. And this cycle is also sometimes known as the limestone cycle. Okay, so let's look at the answers for this. Okay, now calcium. So you see here, this is calcium carbonate, and then this is limestone. So this is the chemical name, this is the common name, and this is the chemical formula. Okay, so the order is like that. All right. Okay. Now, before that, I just want to mention this. Now, those who have printed the notes, you can write the answers there. So those who have not, I have the hard copy with me. I've already printed. When you get back to school, I'll give you the copy. And meanwhile, what you do, you can write the answers in your exercise book, or if you have the habit of taking down notes, you write it in the place where you're writing notes. Okay, later you can transfer it to your notes when I give it to you. Okay, is that all right, students? Okay, now let's continue. So when calcium carbonate is heated, you get calcium oxide. So what do I write here? Okay, good. So what do I write here? I write quicklime or lime. Okay, so this is the chemical formula. So when you add water to quicklime, it becomes slaked lime. So when you add a little bit of water, it is still in the solid state because it can absorb the calcium oxide can absorb the water. So it will still be in the form of a solid. Okay, and what do I write here? It's calcium hydroxide. Okay, so when this calcium hydroxide is dissolved in water, okay, so when you completely dissolve in water, then it forms a colorless solution. All right, so to calcium oxide, when a small amount of water is added, it is still in the solid form, and this you call it slaked lime, and it's calcium hydroxide. But when it is completely dissolved in water to form a colorless solution, okay, then you call it lime water. Okay, so what will be the chemical formula here? It's calcium hydroxide. But the thing is that this is in aqueous state. Okay, so you see the difference. This is a slaked lime is calcium hydroxide in solid state, and lime water is calcium hydroxide in aqueous state, dissolved in water. Okay, now what do I write here? What is when you bubble what into the lime water? Bubble means pass the gas into the lime water. What gas is that? Okay, now remember you've learned before about the testing for carbon dioxide gas. Now, how do you test for carbon dioxide gas? You pass it through lime water. Okay, pass the gas through lime water. So lime water turns cloudy. The cloudiness is because of the formation of a white precipitate. So here, now we know that this white precipitate is calcium carbonate. So what do I write here now? Carbon dioxide. Okay, carbon dioxide. All right, so this is what, so this again you get back the limestone. So this is a cycle. Okay, so these are some of the reactions of calcium carbonate. Okay, good. Those who answered. All right, now moving on. A few more, one more reaction of calcium carbonate. Now, limestone reacts with acid. Okay, limestone reacts with acid to form salt, carbon dioxide, and water. Limestone is damaged by acid rain. Okay, so that this limestone, since limestone reacts with acid rain, buildings or statues that are made of limestone are damaged or corroded. Okay, now what will be the chemical equation for this? Okay, we know that limestone is calcium. We know that limestone is calcium carbonate. Okay. What is the acid present in acid rain? Sulfuric acid. Okay, now what products are formed? You have come across this equation in the topic on acids, bases, and salts. Okay, so you get calcium sulfate plus carbon dioxide plus water. All right. Now, what's the formula for calcium sulfate? Calcium is Ca2 plus, sulfate is SO4 2 minus. Okay, so the 2 plus and 2 minus get cancelled out, so it will be CaSO4. Okay, I'm sure you know the formula for carbon dioxide and water. Yeah, you all know. Okay, good. All right, so that's another equation, another reaction of calcium carbonate. Okay. All right, now let's move on. So this part of the topic is something that is quite new to you. Okay, all right. So limestone, as we learned earlier, can be used as a building material. So these are also other building materials that can be made from limestone. Okay, making cement. Now, cement. So cement is made from limestone. Okay, so all this while we looked at some of the uses of limestone. Now cement is also made from limestone. So limestone is heated with clay to make cement, which is a fine gray powder. All right, now what is clay? Clay is a type of soil. Okay, clay is a type of soil. So this limestone and clay, they are dried and then they are fed into this furnace. So this is called a kiln. Okay, so in chapter 9 you learned about different types of furnaces, blast furnace, and then not only different types of furnaces, different types of vessels where reactions take place. Okay, like the blast furnace, and then you learn about the reactor for the Haber process, and then you learn about the diaphragm cell. So now this is a kiln. Okay, so cement is made in the kiln. The dried and powdered limestone and clay are fed into the kiln, and in this kiln the temperature is quite high. Okay, so you can see there's a flame here towards this end, so the temperature is quite high, and these limestone and clay, they keep on, the kiln rotates and the chemical reaction takes place between the limestone and the clay. And by the time it comes out here, it forms cement. Okay, and this kiln is quite long. It can be as long about 49 to 50 meters. It's quite long. It's a quite long structure. Okay, all right. So here, what you see here, this gray color powder is cement. All right, so to this cement, to this mixture, okay, so to this mixture of limestone and clay, gypsum is added. Gypsum is calcium. Gypsum is added. Gypsum is calcium sulfate. Okay, so when gypsum is added, it improves the quality of the cement, and when to this cement powder, the dry powder, during the construction, during the building time, water is added. Okay, when water is added, and then it will set into a very hard substance, and that is how that is the reason why cement is used as a building material. Okay, so we are not going to go so much into the detail of how cement is made, though it is a very long process. But for you, it's enough for you to know that in cement you have limestone, clay, and gypsum, and cement is a gray powder, and cement is used as a building material, and cement is made in a kiln. Okay, so for the benefit of everyone, I will show you a video on the making of cement. Okay, you can see how it's a very detailed process, but I want you to observe the kiln and also the color of cement, gypsum, and so on. Okay.
Confuse the terms cement and concrete. Cement is a fine gray powder that's used to make concrete. It's also an ingredient in the mortar that masons use to lay brick and stone. Cement also goes into soil cement, a material that's used in paving roads, building dams, and lining reservoirs. The action begins at the limestone quarry. The limestone near the surface has a high content of the minerals silica, iron, and aluminum oxide. Deeper down, the limestone is more pure, containing less of those minerals and more calcium carbonate. The plant uses both types of rock, altering the proportions to make different types of cement. Workers drill holes in the rock wall in which they plant powerful explosives. For safety, the workers have to position themselves behind the area they're blasting, maintaining a distance of at least 50 meters. After the explosion, loaders move in. They transfer the limestone rocks to 50-ton capacity dump trucks. The trucks then haul their cargo to the cement plant nearby. At the plant, the trucks dump the rocks into what's called the primary crusher. The rocks can be as big as a piano. The primary crusher reduces them to about the size of softballs. There's a constant spray of water to keep the dust from billowing up and settling on the chutes. From there, a conveyor transports the rocks to the secondary crusher. It reduces them further to about the size of golf balls. Rock high in calcium carbonate and rock low in calcium carbonate are crushed separately. Now it's time to mix the two. The ratio varies according to the type of cement they're making. This overhead machine called a tripper makes piles of the required proportions. They call this the raw mix. Then a reclaimer loads the raw mix into a grinding machine called a roller mill. Depending on what minerals are already naturally in the crushed rock, the factory adds extra minerals such as silica and iron. Certain types of cement also require aluminum oxide. The roller mixes and grinds the ingredients uniformly, producing a dry rock powder called the raw meal. Now the powder goes into a preheater. The temperature of the powder is 80 degrees Celsius upon entering. Within 40 seconds, it gets more than 10 times hotter. This begins the process of bonding the minerals together so that they'll later harden when hydrated with water. The preheater is equipped with what's called a flash calciner. In about 5 seconds, it removes 95% of the carbon dioxide in the powder through a chemical reaction. This isolates the lime, which is the most important element in cement. From there, the powder moves into a rotary kiln, a huge cylindrical furnace. It's set at an angle so that the powder moves from top to bottom a distance of 49 meters. The kiln rotates about 2 turns a minute to ensure the material travels through at the right speed. The burner's gas flame at the bottom reaches a scorching 16 to 1700 degrees Celsius. As the powder approaching it reaches the 1500 degree mark, it fuses into pieces about the size of marbles. These pieces are called clinker. As the clinker leaves the kiln, large fans cool it down to between 60 and 80 degrees Celsius. It's important to cool the clinker quickly in order to have quality cement. From here, the clinker goes to the storage area. The last stage of cement making is called finish grinding. They add some gypsum to the clinker. The precise amount varies with the type of cement they're making. Gypsum delays the cement's setting time so that it can be worked for up to 2 hours before hardening. The cement mills are called ball mills because they contain metal balls, about 150 tons of them in the largest mill. As the mill rotates, the balls crush and grind the clinker and gypsum into a fine powder.
That video was about the making of cement. Okay, so students, when you watch the video, I hope you observe how a limestone quarry looks like, and the structure of the kiln, and how cement looks like, and also how the gypsum looks like. Okay, so moving on, we have concrete here. So cement is one building material that is made from limestone. Now, concrete is harder than cement. Now, to make concrete, cement is mixed with sand, water, and aggregate. Now, aggregate are small stone pieces and gravel. Okay, so the bigger pieces of stone are broken into smaller pieces like this, and this is what you call as a gravel. Okay, now reinforced concrete. Reinforced means to strengthen something. Okay, so when you already learn all these subjects, so during revision time, what you have learned is kind of what you can say, it's kind of strengthen you know whatever you didn't were not clear earlier, you get it cleared, so it kind of strengthens what you know. So reinforced concrete is to strengthen the concrete. Concrete is already hard. It says here concrete sets like stone. Okay, now so this concrete can be reinforced by adding steel rods or cables. Okay, so when you pass by construction areas, you can see a lot of these metal structures, and people will be adding the concrete to it. So this is called reinforced concrete. Okay, and mortar. Mortar is cement that is mixed with sand, water, and lime. Okay, lime is calcium oxide, and mortar is a binding agent. So what people do is they lay bricks, and then to that they lay bricks, and then you can see the gray color mortar being applied. So this will hold the bricks together, and they can build a wall. Okay, so cement, concrete, reinforced concrete, and mortar are other building materials as well. Okay, all right, and you need to know what substances are present in cement and concrete and so on. You might not be asked to write an essay on this, but there are questions based on these building materials. Okay, so please study them. Okay, now we learned earlier that glass is also a building material. Okay, so you can see that parts of sometimes even parts of a whole wall is made mostly of glass. Okay, so let us see how glass is made. Now, glass is made by heating together a mixture of limestone, sand, and sodium carbonate. All right. Okay, so limestone or lime can be used here. So because of the heat, the limestone eventually will become calcium oxide or lime. All right. So during the heating process, a chemical reaction takes place, and you get glass, which is a mixture of calcium silicate and sodium silicate. Okay, so the limestone reacts with sand to form calcium silicate. The sodium carbonate also reacts with sand to form sodium silicate. So glass is a mixture of calcium silicate and sodium silicate. Okay, all right, now let's look at a summary of the uses. So this is actually based on what you have learned before. So we are learning about limestone. Now limestone can be quarried and it can be used as stone for buildings, or it can also be part of the aggregate. When limestone is heated with iron ore and coke, you get iron. Okay, so this is regarding the extraction of iron. When limestone is heated, you get quicklime. Quicklime is used to neutralize acid, and when water is added to it, it becomes slake lime, which is also used for neutralizing acid. Okay, limestone, when it is heated with clay, forms cement. To cement, you add water, sand, and aggregate, you get concrete. Okay, any questions on this limestone and building material, student? Because before we move on to the next part. Okay, now we move on to the last part of the chapter 9, that is the economics of the chemical industry. So in chapter 9, throughout chapter 9, we're learning about the different chemical industries. We learned about the production of iron and steel, and then we later learned about the manufacture of ammonia, the production of fertilizers, sulfuric acid, and so on. Okay, so the production of chemicals and chemical industries and chemical industry has rapidly grown in the past 50 years. And this chemical industry is an economically significant part of the whole industry. Okay, there are so many other industries, food industry, textile industry, and so on. But chemical industry is also economically important because they deal with the production of goods and then the making of substances and so on. So they make a lot of money, a lot of people are employed there, and then they also, as consumers, we also buy the product. So there is a lot of money moving there. All right, so chemical industries, what do? They produce a lot of, they produce medicines, fertilizers, polymers like plastic, which you will learn later. So all of these things we use in our day-to-day life, and they have kind of made our lives a bit more comfortable, isn't it? Okay, so these products are useful to us, but at the same time, chemical industries have caused adverse effects on our health and environment. Okay, adverse means negative effects. Okay, now who can tell me what are the negative effects that are caused by the chemical industry? You can, we have learned in chapter 9, or you can also tell me from where you know, something that you have heard on your own or read somewhere. Yes, we learned that sulfur dioxide is a poisonous gas. Okay, when people who breathe it, they can suffer from respiratory diseases. Okay, so that causes adverse effect on our health. And how does it affect the environment? Okay, it causes sulfur dioxide gas causes acid rain, and there are other pollutants that are produced from industries that can cause photochemical smog, and then the damage to the ozone layer. So all these are damage caused to the environment. Okay, so basically if you look at chemical industries, they are causing pollution of everything. The air is polluted, the water is polluted, and the land is polluted. Okay, but the thing is this, is that it's not that these cannot be controlled, or these cannot be overcome. It's just some effort on the part of the people who run this industry to take care of the environment. They just have to pay a little bit extra to make sure they don't pollute the environment. Okay, so if they do this, these harmful effects can be overcome. All right, so there's so many ways to overcome these harmful effects. I've just put a few here. Okay, one of this is flue gas desulfurization. Okay, so flue gas is waste gases that come from industry. Flue gas refers to the waste gases that come from industries. Okay, so if this flue gas is allowed to allowed to get into the atmosphere, what does it do? It can, it can cause health problems for people. And if it is sulfur dioxide gas, it can cause acid rain. Okay, so what people have to do now is, what the industries have to do now is, they have to treat the gases before they are released into the atmosphere and create more harm for people. For example, like acidic gases such as sulfur dioxide, they are removed by scrubbing. Okay, sulfur dioxide gas has to be removed by scrubbing. Now, what does scrubbing mean? This sulfur dioxide is reacted with calcium oxide. Okay, reacted with calcium oxide. So sulfur dioxide is an acidic gas. When it reacts with calcium oxide, the sulfur dioxide will be neutralized. Is that clear? So the people in the industry, they have to pay a bit more to have these scrubbers installed in the industries. Okay, so if they do that, these waste gases will not get into the atmosphere. All right, so now let's see how water pollution can be avoided. Sometimes certain industries, they just release their metal compounds, metal compounds into the water, and this can badly affect people's health. So nowadays, what they have to do is that these metal compounds have to be treated with sodium hydroxide. Okay, so we learned earlier that metal ions, when they react with sodium hydroxide, they form precipitate. Okay, so when the metal ions form the precipitate is a solid, so it can be filtered out and it can be removed. Okay, because many metal compounds have the ability to dissolve in water, and it's very difficult to separate it that way. But if they react with sodium hydroxide and they form the precipitate, then it is easy to filter out the metal compounds. Okay, some poisonous metal compounds are like metal ions are like mercury. Okay, so any metal compound, too much of it, it's going to affect our health, though we need trace amounts of metals in our body. Okay, now solid waste products have to be disposed of safely. Okay, industries, they certainly produce solid waste, so this solid waste cannot be just dumped anywhere and allowed to just decay on its own. It has to be disposed of safely. Okay, so like we learned in the extraction of iron, slag is a waste product. Okay, so this slag shouldn't be left lying around. So what they do now, they use the slag to make roads. So the waste is disposed of safely. At the same time, it's also used properly. Okay, so these are some ways that industries can do to help to prevent harming the environment. Okay, so now let's see how we can preserve the environment. So how can we preserve the environment and supply of valuable raw materials? Okay, so I'll give you a few minutes to read this part. There are just a few points there. So I want someone to summarize and tell me, or just tell me what is the main idea here. Okay, you want to add any of the ideas that you have read before, you can use that, or you can just tell me what the main ideas here are. Okay, I'll just give you a few minutes because there's not you don't have that many points here, just a few points only. Okay, there's one answer. Very good. Somebody says that we have to recycle, reuse, and reduce. Yes, basically the idea here is to recycle. Okay, it's economically beneficial to recycle metals rather than to extract them. Okay, so when we learn that, when you have to extract metals, you have to go collect the raw material first, purify the raw material, and then extract. But if we can recycle whatever is already there, it is, it is much cheaper. Now, recycling is fast becoming a major industry and it provides employment for people. So you can see recycling centers, quite a number of recycling centers nowadays. So people can earn money. They can earn a living by recycling objects. Okay. Recycling conserves the raw materials. So instead of going and taking the raw material from the ground, instead of taking the ore from the ground all the time, we can recycle whatever is already there. So we don't have to, so that the raw material will remain there for a longer period of time. Okay, so your children, your grandchildren, they can all use them for the coming generations. Okay, now less energy is needed to recycle an object instead of making it completely new from raw materials. Okay, so energy consumption is also less. Recycling helps to lessen the use of landfill sites. Now, landfill sites are huge areas where our waste is disposed. So waste that we throw, our household waste is collected, and then it is finally taken to the landfill site. So together with the household waste material, all these metals, used metals are also dumped. Okay, so if we learn to recycle, then that will lessen the use of landfill sites. Okay, these landfill sites are so huge. Sometimes some of the space can be used to like build hospitals or build schools. So instead of using large area for throwing rubbish, if we learn to recycle, we can lessen the use of the landfill site. Okay, some of the objects that can be recycled are aluminum, steel, glass, plastics, and paper. Okay, even though we can't recycle everything, at least some of these can be recycled. Okay, so you see the bins now with the compartments where you can throw paper, plastic, and glass. Do you do that? Okay, so we can also play our part in saving the environment. So if we throw it in the correct bins, then it is easier for the people to recycle. Okay, so to finally conclude, recycling not only saves energy and raw materials, it also avoids the need for huge piles of rubbish in landfill sites. Okay, so let's do our part also in saving the environment. Okay, so with this, we finish chapter 9. Okay, any question on chapter 9, students? So chapter 9, initially we started with the extraction of iron, then conversion of iron to steel, and then we learned about the Haber process, the contact process, limestone, and so on. Okay, do you have any questions? Okay, if you have no questions, I will end this session. I've already shared the link for your homework for this week. Make sure you complete your homework and see you all in the next class. Bye.